The next topic in our last review packet is average rate of change. And average rate of change is something that is definitely going to be tested on the EOC because it is a prioritized standard, meaning that you will use it in other math and science classes as you move through high school. The average rate of change formula is given to you on your formula sheet, but it doesn't say average rate of change formula. It says slope formula. Slope and average rate of change are synonyms, so that means that they mean the same exact thing. Average rate of change is just asking you the slope or the average slope between 2 points. And you can do this from a graph, a table, or a function, especially using your calculator. So example number 1 says, find the average rate of change of the quadratic function shown on the graph over the following intervals. Intervals are always your x values. So the interval 2 to 5, you have 2 x values. 2 is your first x value, 5 is your second x value. So it's very important to remember that intervals represent x values. So now I just need to find where on the graph x equals 2 is, which is right here. And the point that corresponds to x equals 2 would be -9. If you look at the y value of when x equals -2, it's right here at about -9. Then I need to look at the y value that corresponds to x equals 5. So x equals 5 is right here. My y value is -12. Once you have your 2 coordinate points, which you're always going to need, you are going to label them x1, y1, x2, y2. Using your 2 coordinate points, you're just going to plug in these values to your average rate of change formula. So y2 comes first, minus y1, -9. Now I'm going to put, every time I plug something in, I'm going to put it in parentheses. Divided by, or a fraction, the denominator is 5 minus 2. So I have my y2 minus y1 over x2 minus x1, and I can type that straight into my calculator. So if I go alpha y equals enter, I can do parenthesis -12 close parenthesis minus parenthesis -9 close parenthesis over parenthesis 5 close parenthesis minus parenthesis 2 close parenthesis, and I get -1. So the average rate of change from here to here is -1. Now we're going to do the same thing, but this is a different way for them to write intervals. Remember, your intervals are going to be x values, so it wants it from 0 to 4. So my first coordinate pair needs to be 0. My second coordinate pair needs to be 4. First, I have to find my y values that correspond with these x values. So the the y value that corresponds with x equals 0 is right here at 3. And the y value that corresponds to x equals 4 is down here at -13. I'm going to do the same thing. I'm going to do y2. So let me label these x1, y1, x2, y2. My y2 is -13 minus y1, +3. Over x2, which is 4, minus x1, which is 0. So I'm going to type that into the calculator. Alpha y equals enter. -13 minus 3 over 4 minus 0. And I get -4. So the average rate of change between these 2 points right, so 0, 3, here is -4. And that makes a lot of sense because it's a lot steeper negative slope than when we looked at the average rate of change between these 2 points right here, which is also negative but less steep than this right here. The second way we can calculate average rate of change is from a table, and this is my personal favorite way to calculate average rate of change because you don't have to do much searching. You do have to be able to identify that this interval is two x values, so we are going to start with our x values once again. X equals -3, x equals 0, but then you just have to find them on this chart. So x equals -3 is right here, x equals 0 is right here, and I'm just going to find the y values associated. So when x equals -3, y equals 100, and when x equals 0, y equals 12.5. Label my points x1, y1, x2, y2. Use my average rate of change or my slope formula. y2, 12.5 minus y1, which is 100, divided by x2, 0, minus x1, -3. So I'm going to type that in here. Alpha y equals enter. Alpha y equals enter. 12.5 minus 100 divided by 0 minus -3, and I get -29.167. It is totally fine that you get a decimal. Just because you get a decimal doesn't mean it's wrong. Definitely look and check your multiple choice options, or just trust your gut when you're writing it out. I'm going to do the same thing for D. My x values are going to be -1 and +2. So I'm going to use the coordinate points -1, 25, and 2, 3.125, x1, y1, x2, y2, and I'm going to plug it in. So I have 3.125 minus 25 over 2 minus -1. Alpha y equals enter, parenthesis 3.125 minus 25 over 2 minus -1, and I get -7.29. The last way you can calculate average rate of change is from a function, and they want the interval -2 to 8, which can also be written as -2 to 8 with brackets like that. We still need two coordinate pairs. So because these are my x values, I'm just going to go ahead and plug them in. And now the easiest way to do this is to use your calculator. So I'm going to put this function in the calculator in my y equals menu. So if you missed that, I cleared out my calculator, clicked y equals, and made sure there was nothing in my screen. Then I'm going to type the function -2x plus 4. And then I'm going to go to my table. See how it says table in blue right here? I'm going to click the blue button and then click the button where it says table above it. So now I need to find the y values from this table with x equals -2, so that would be 8. And then when x equals 8, y equals -12. So I'm going to do the same thing. x1, y1, x2, y2. So using my slope formula, I have my y2, which is -12, minus my y1, which is 8, over x2, which is 8, minus x1, -2. Clear everything out. Alpha y equals enter. -12 minus 8 over 8 minus -2. And I get -2. And really, if you think about it, average rate of change is the same thing as slope. And because we're looking at a linear function in slope-intercept form, which is y equals mx plus b, you should be able to identify that slope and average rate of change are the same thing. So the average rate of change for a linear function is constant. It is going to be -2 between any 2 points. So that's why you can identify it very quickly in a linear function, because linear functions, slope is the synonym to average rate of change. It is the same exact thing.